Alright, today we're going to start integration by substitution. There are many integration techniques, but you actually learn those in Calc 2. This is the one technique that we learn in Calc 1, and that's integration by substitution. So what we're going to do is we're going to get started, and we're going to go ahead and talk about how you would do something along these lines. If you look at this as it is now, I'm going to explain to you why you can't do it using the old method that we've been doing. This is what it says. You cannot distribute an x squared through. Had this been to the first power, we'd have no problem integrating this. So one of the things they do to start to teach you integration by substitution is they talk about just identifying the u and the du. And that's all we're going to talk about here at first. So what we're going to be doing is we're going to be transferring an integral into an integral with respect to u so that we can integrate it. So let me go ahead and try to explain that to you. Typically, and this is just a little side note for you, whatever's inside of a set of parentheses is what you want to make your u statement. So I'm going to show you off to the side. If I go ahead and write down what u is equal to, and we're going to just let u be x cubed plus 1. What we can now do is, because we need this dx when we go to rewrite or integrate, we're going to have to take the derivative of this. So we're going to write du over dx is equal to 3x squared, which makes du actually equal to 3x squared dx. Now, I will eventually, here probably even on this next problem, skip that step, and I'll just always put the dx on the other side. Now, it does not tell me to evaluate this integral, but I do think it's important that you guys go ahead and see why this works out the way it does. If I was to replace each of these things with u, I would have this part I said was u, so I'd say that is u, and it'd be to the 1/2 power. Now the other parts that I have left, I need to find a d or an x squared and a dx. Now I have exactly that right there. So what I want to do is I would solve for that x squared dx by moving this 3 to the other side, which would create this 1/3 du. So then all I would have to do to replace my x squared dx is write in a 1/3 and a du. Now notice where I put that constant. We're always going to put those constants out in front of the integral. Now it does not say to go ahead and finish this, so that's all I'm going to do. Later we will evaluate the integral. So this problem again says determine whether it is necessary to use substitution to evaluate the integral. We do not have to evaluate the integral. We'll actually do that on the very next problem. So let's go ahead and think about whether or not we need to use some substitution in this. This would say x times x plus 4 to the 1/2 power dx. Since there is no way to distribute that through, this would definitely need substitution. There's no way to simplify this. On this one, again, we could integrate the cosine of x squared, but we could not integrate what we have here because we have two x's being multiplied together and there's no way to simplify this. So this would also require substitution. Now we will do examples like each one of these so that you can see how substitution will be used. I'm going to see if I can fit this into this video. So this one actually says to evaluate the indefinite integral. And what I'm going to go ahead and do is first rewrite this. So I have 3 minus 4x squared to the 1/3 power times negative x, or negative 8x dx. Now I told you when you make your u statement, you're typically going to pick what's inside the parentheses. So I'm going to try 3 minus 4x squared. When you take the derivative of this, you hopefully get something that was left over here, which is exactly what we got. I called this u, so I'll write u to the 1/3. And then I got exactly what I needed. Look how those two things match up exactly. So I get this. So now I'll just raise this by 1 and put it over it. This is an indefinite integral, so I have to remember to put my plus c. And so I get 4/3 u to the 4/3 plus c. Now we're not supposed to leave our answers in terms of u because it was an x's to start with. So my final answer would be 3/4 3 minus 4x squared to the 4/3 power plus c. Alright, we're ready to do another indefinite integral. So once again, there isn't really a whole lot to rewrite in this problem. So what I'm going to go ahead and do is just say, alright, we normally need to pick what's inside the parentheses, and I'm always going to try that first, and if it doesn't work, then we'll talk about other techniques that we can do. But right now, this is going to typically work. We're going to take the derivative of this statement once I've chosen my u, which would be 4x cubed dx. Now let's see how we can start to replace these values. So right now, I'll go ahead and replace my u. So I'll write this as u squared. And then if I look at what's left, I have an x cubed and a dx. I only want the x cubed dx, so I'm going to move this 4 to the other side by dividing each side by 4. And that gives me exactly my x cubed dx. So I'll put in here a 1/4 and a du. I'm always going to put that constant out front because I can figure it out later. And what's on top of this is just a 1. So before I take the integral of this, I would go ahead and rewrite it as u to the negative second du. So now I'll take the integral of this, which would be u to the negative first over negative 1. This is an indefinite integral, so I would put plus c. So now I end up with 1/4 times negative 1, which would be negative 1/4. U to the negative first, well, that would put a u on the bottom, plus c. When you multiply 1/4 times a constant, it doesn't change the answer. The only thing else we need to do is replace our u. We've got to remember to replace our u because we were integrating with x's. So my u is equal to 1 plus x to the fourth, so I'll replace that, and then I'll write plus c. I want to point out to you on these, and I'm not going to do a bunch of these examples, but I do want to mention to you that on 30 to 38 even, these are all normal integration, meaning they don't require you to use substitution. So I want to go ahead and show you one of these. Let's go ahead and look at number 30. 30 says x squared plus 1 over 3x squared dx. Now, even though there's a set of parentheses, these do not require substitution because we know how to integrate this. We have an x squared, we can integrate that function, and we have a, this would be a 1/9 x to the negative second, and we know how to integrate that as well. So this would just straight out be, let's integrate this, x to the third over 3 plus 1/9, raise it by 1 and put it over that power, plus c. This would give me 1/3 x cubed plus, I'd have my 1/9, well this would be negative, and then the x would go on the bottom down here, plus c, and that would be my final answer. So when you guys are working through problems, always make sure that you can't just integrate it as normal. You're going to have to recognize substitution. Now, this says solve the differential equation. What that is actually saying is that we really have this dy equals 10x squared over the square root of 1 plus x cubed. And then we'll write our dx over here. What we're really doing is we're integrating both sides when we're solving the differential equation. Well, the integral of dy with respect to y would be y equals, and now we're going to integrate this right-hand side. The right-hand side is not easily integrated, so we're going to have to make a u statement. I'm going to pick what's in the parentheses right here, which would be the 1 plus x cubed. I'll take the derivative of that, and we'll hope that we get what we need. We get a 3x squared dx. Not exactly what I need, but I can work with that. So what I'm going to actually start out by doing is putting this 10 out front. So I move this 10 out front. I have on the bottom of this, I have the square root of u. So I've taken care of this part. And so I only need an x squared dx. Well, I only need the x squared dx, so I'm going to move the 1/3 or the 3 to the other side. So it makes it a 1/3 u, a 1/3 du, x squared dx. So now I can replace my x squared dx with my 1/3, which would make that be 10/3 du. Now I'm left to integrate this, and I'll have to do that on the next video. Okay, this is where I had left off. Now let me go ahead and separate the parts that I've done so far. So I had gone ahead and separated my dy over dx. I've integrated both sides and made a u statement and replaced my values. So now I'm ready to find my solution, which I'm going to have to integrate. This would be u to the negative 1/2 du. So that's going to give me the answer of 10/3. And then I'd raise this by 1 and put it over that power, and I'd have plus c. Well, that gives me 20/3 the square root of u plus c. Now remember, we're not supposed to leave it in terms of u, so we're going to substitute our u value back in, which was this 1 plus x cubed. So our final answer would be y equals 20/3 the square root of 1 plus x cubed plus c. In this next problem, we're going to solve another differential equation, so I'll go ahead and start by moving my dy to the other side, or my dx to the other side, excuse me. I know this requires substitution because I don't know how to integrate something with a fraction, so I'm going to make my u what's underneath this square root, x squared minus 8x plus 1. So when I take the derivative, I get 2x minus 8 dx. Now, if you start to look at what you have, you need an x minus 4. Well, I can actually see an x minus 4 here if I just do some factoring. So what I actually want to go ahead and do is I want to rewrite this now because I was integrating both sides. So the integral of dy would be y. And the integral here, well, I haven't integrated it yet. I need to go ahead and rewrite this. So it would be the square root of u. That takes care of this part. I need an x minus 4 dx. That's right here. So I need to move my 2 over and make it a 1/2 du is equal to this x minus 4 dx. So I'm going to put my 1/2 out front, like I always like to do, and my du here, which means there's just a 1 sitting here. So what I really have is I have the integral of u to the negative 1/2. So I can now take the integral of this, which would be u to the 1/2 over 1/2 plus c. 1/2 times 2 ends up giving me a 1, so really all I have is the square root of u plus c. And then last step, plug your x's back in. So the answer to this differential equation would be the square root of x squared minus 8x plus 1 plus c. Last example, it's asking me to sketch 2 approximate solutions of the differential equation, and I can actually show you that in class. We're supposed to use the slope field, and I can't create that on here, so I'm going to leave that for class. We're going to use the integration to find a particular solution of the differential equation. So in order to do that, we actually need to solve this differential equation, and it does require u substitution. So my u statement is going to be x cubed minus 1. So du ends up being 3x squared dx. I'm going to replace then, because I'm integrating both sides, this ends up being y. Y equals, I would have my u taken care of by writing u squared and then adding the x squared dx, which I have, as long as I move my 3 to the other side. So I end up getting 1/3 du. So now I can take the integral of this, which gives me 1/3 from the 1/3 out front, u to the 3rd over 3 plus c. So I get y equals 1/9 u to the 3rd plus c. Now we're actually supposed to find the particular solution to this, which means I'm going to be using this value for y and x. So coming over here to the side, I will substitute 0 in for y, and I will substitute the 1 in for x, but I need to go back here and make a quick correction, so I forgot to put my x back in. My x, when I put that back in, is x cubed minus 1 plus c. So now I'll go ahead, I'll make this y, and so I have 0 equals, and I'll plug in 1. Well, that ends up giving me 0, so my c value is 0. So my actual solution would just be this portion, because I'd have 0.